Define electric field strength. So what is electric field strength? Yeah, no. No.
Electric field strength.
Getting closer. You remember that F equals QE, don't you? Oh yeah. So E equals F over Q. So electric field strength is the force experienced by a charge. No, I'll write it down since you don't remember it. Electric field strength is the force acting on a unit charge in and from an electric field. Right, part 2. That was part 1. Electric field for a positive charge. So do you remember how it goes for a positive charge? The electric field goes outwards, doesn't it? And then the lines of equipotential, how do they look? Circles. Alright, so that's an easy 4 marks there for, that's actually part 1 and part 2.
This question repeated next year too after this.
Huh?
Because this question is repeated in the next paper, 14, 15. The paper 14, 15.
The exam plan I gave you?
No, the past paper.
The past paper?
Yeah.
Oh, okay.
Yeah. Because I've done the same question.
Okay. Sometimes that happens, yeah. Determine the electric field strength at a distance 5 centimeters from a 4 micro. Okay, so what's the formula for electric field strength? That's 1 over 4 pi epsilon 0 Q over or squared, isn't it? Yeah, the potential is or, I think. Anyways, Q is 4 microcoulombs and the radius is 5 centimeters. So I get an strong electric field. Right. I get 14.38 meganewtons per coulomb, which is correct.
It's 14.3 F?
14.38. B.
Need to open the 8 to...
Oh yeah. You have a 9 microcoulomb and a -2 microcoulomb, and they are 10 centimeters apart. Determine. Right, so they want the point where the forces between them will be 0. So we'll call this distance x, and well, where do you think it would be? No, the next one. Yeah, I'd say it'd be something like this. So we'll call this one x. No, I'll call the smaller one x. X and 0.1 minus x. So the electric field strength from the one on the left is, I'll write an E from the 9. We want that to equal the E from the -2. And if you remember, the formula for E is 1 over 4 pi epsilon 0. That would be 9 micro over 0.1 minus x squared. That should equal 1 over 4 pi epsilon 0 2 times 10 to the -6 over x squared. So what's great is that ugly constant cancels and the micros cancel. So you're just left with 9x squared equals 2 times 0.1 minus x squared. So you have 4.5x squared equals 0.01 minus 0.2x plus x squared. So you get 5.5x squared plus 0.2x minus 0.01 should equal 0. So you have 55x squared plus 2x minus 0.1 equals 0. 550x squared plus 20x minus 1 equals 0. Alright, so we have to use the formula here. And I got x equals 0.028 meters from the minus 2 microcoulomb. Nope, wrong. Fail. What do you mean epic fail? It's a little off. Yeah, a bit. Right, where did I go wrong? Is it 9 and 2, isn't it? Right, so that's correct, that's correct, that's correct. And that's correct. Yeah. So 9x squared is correct, and 2 times that's correct. 9 divided by 2 is 4.5. 0.1 squared. Okay, so that's right. Twice the first by the second. Second squared. 4.5. No. The problem. 4.5 minus x squared, that should be 3.5, that should be 35, that should be 350. Indeed. .032 meters. It is correct. Now, they measured the x. Now, does it care which way it's... Yeah, you can say it's 0.032 from the right, or if you want to measure it from the left, you can. That doesn't look right anymore. No. Well. Weird. My answer, let's double check, 350, 20.
You get 2 answers.
I should get 2 answers, I do. So, I'll just write them down again. I get 0.032 meters or minus 0.089 meters. Yeah, he wants both answers actually.
No.
But he only... okay. So, which answer do you think they take? Actually, you take the minus answer. I'll have to draw to see why. Here is the 9, the positive, and here is the negative. So if I have 2 answers, one positive, it means it's here, or the negative answer actually puts it outside here. Now, if you look here, there's a force pulling it to the, well, it doesn't actually know what this one is. Let's imagine that this is positive. It'll be pushed to the right from this one, and here it will pull it to the right as well. So this answer seems wrong because it doesn't seem like the force could be 0. Whereas if you look here, if this is a positive, it will be pulled to the left to the negative, but this positive here will push it to the right. So crazily, this is actually the right answer, and this is the answer to reject.
If you don't reject the answer, you just write
You won't get the full marks. He gives you a mark for this. I know, sucks. Okay.
I thought he did something somewhere.
See part 1. Define magnetic flux density. So I think the easiest formula to use might be this one, F equals BIL. So B will be F over IL. So you could say it's the force acting on a unit length of conductor. Oh, sorry, there's a little star here I forgot to write in a bit. The force acting on a unit length of conductor carrying 1 amp of current, and the star which I left out, force acting on due to a magnetic field. So one definition is if you have 1 meter and you have 1 amp here, 1 meter and 1 amp, and you have a magnetic field passing through it, it's the force here. And actually not only that, but I should also say the force at right angles as well.
Yeah,
It's sine theta if it's at an angle, yeah. Okay. Part 2 is sketch the magnetic field for our current. Can I go down a bit? Well, actually, this definition is in your notes. So, yeah, imagine there's a current here, and we have it going. Let's say this is going into the page, the current. So which rule do we use here? Do you remember?
Right.
There's a right-hand rule. If this is the current, then the magnetic field is going this way around. So on my picture, my magnetic field is going this way. Yeah. And then this is the field here. And that is correct. And finally, for this exam, huzzah, you have a length, you have a current, you have an angle, and you want the flux density, and you have a force. So this is our F equals BIL, as you said, Fahad, sine theta. So we want the B would equal F over BIL sine theta. Sorry, what am I doing? Duh. There's no B here. I do, actually, I do. I'm going straight to the canteen after this class. 3 times L, which is 5 times 10 to the minus 2 times sine theta. And the theta is 30, but actually I need to have my calculator back in degree mode. And I get 47.5 millitesla, which is correct. And that is the end of version 4. Okay. So I'll close this now. Yes?